All right, welcome everyone. Thank you so much for coming today. My name is Rosalie, and I'm the Director of Community and Content at H2O.ai. And today, I'm just so excited to be joined by 5 fantastic panelists. To start off, I'm just going to ask them to introduce themselves.
Hi guys, my name is Alan Capalik. I'm the founder and CEO of FastData.io. We're a real-time GPU-native streaming data engine.
Hello. My name is Jitender. I'm VP of Products and Design at Kespry. Kespry is end-to-end aerial intelligence company. So we'll talk more about Kespry.
Awesome.
Hey, I'm Todd Mostak, co-founder and CEO of MapD. We're basically a GPU-accelerated interactive analytics platform for interactive querying and visualization of data at scale.
Hi, I'm Devon. I'm the VP of Engineering of Enlitic. We aim to make healthcare more accessible and more accurate. More specifically, we use deep learning in radiology to detect and diagnose diseases in medical scans like X-rays, CTs, and MRIs, sometimes at superhuman levels, superhuman levels of accuracy, and we partner with hospitals to help support their doctors in making better decisions.
Hi, William Rashan. I'm the Chief Strategy Officer with datascience.com, and we are an enterprise data science platform.
Awesome. All right, so to start off our chat today, I have a question for all of the panelists. Could you maybe share an example of how your customers are using AI?
Well, one of the industries that we're hitting up is cybersecurity. So the cybersecurity is kind of like what I would compare to is a high-frequency trading application, which is you have to tell the story like in real time because hackers are in and out of networks real fast, like 30 seconds on average. So the way they're using it is basically applying their models to real-time data streams to tell a story from a perspective of what's going on the endpoints, machines, your laptop, stuff like that, to see if there's any malicious behavior activities happening there.
So for one of the industries we play in is the inspection. Just imagine the status quo when you call up for roof inspection. The insurance company is sending a claims inspector to your site, and that person is coming in and it's doing the roof inspection by climbing on the roof, using an iPhone, taking images, doing manual measurement. So that's the status quo we're fighting in one of the industries, and our solution is fully automated. So our intent was from day one is to kind of automate the parts of the workflow. The claims inspector has it on site. So what Kespry solution does is the inspector takes the Kespry drone, which we assemble in Menlo Park, and that drone is fully autonomous. You just plan a mission over the rooftop, and within minutes you have the data. So that's the biggest advantage of our technology is like within seconds you have high resolution imagery, and that imagery becomes available in Kespry Cloud, and all the data with that imagery, like the roof wireframes, the roof dimensions, all become available. And this is where we use deep learning to automatically detect damages related to hail, water, rust, and wind. So that's one of the use cases in P&C insurance industry that we are tackling very well.
Yeah, so Volkswagen has obviously a huge amount of data, and they've gone all in on the kind of the AI revolution. And in fact, they've been using H2O, XGBoost, GLM, doing things like predicting part failure based on hundreds of different factors, right? But one of the issues they had is, it's great that they're doing this AI, but they want to be able to explain it, and they also want to be able to interrogate these black box models. So MapD is a great platform for them where they can actually basically do a prediction on a dense grid of inputs, and then basically interactively walk through with their decision makers and see exactly why the model is doing what it's doing. They can also use MapD on the front end of doing interactive feature engineering for the inputs to put into their models.
So artificial intelligence has been used in healthcare for decades now. In general, people like to call it computer-aided diagnostics or detection, where essentially it's just having some form of software automatically make some level of prediction given a medical image. So in general, how hospitals have been using up till deep learning is replacing a lot of older techniques, but people would use traditional computer vision specifically around trying to triage patients, which essentially means to prioritize them. So if you have a big backlog of hundreds of patients that need to get treated, how do you make sure the most severe cases get seen first? And artificial intelligence and computer vision helps you prioritize which patients should get seen.
So we have a lot of our customers using AI and ML and deep learning. I'd say one interesting use case is for customer service. So we have one of our customers that analyzes all of their device logs to automate a workflow to look at potential issues with networking in households and proactively communicates with those consumers via email and customer service channels.
Awesome. So another question I have is, these are all really fascinating use cases, but a big focus is ROI. What's the money savings? What's the time savings? Could you guys maybe just give an example of the types of savings your customers are seeing, either in time or in money?
Yeah, I could take that quickly. So the metrics that they're typically looking at are time to model deployment. So how quickly does it take to actually get from research to a production model. So that's a typical unit of measure, and it's usually trying to shorten the cycle or the number of man hours going into that. And then once a model is produced and it's working and it's in production, they're typically looking at revenue or cost impacts on that. So the customer service example, it would be time to response. So how quickly can you shorten the cycle on proactively reaching out to a ISP or a customer to correct any issues with the devices that they're working with.
And in our case, our deep learning models are embedded in our applications itself. So when the pipelines kick off, when we have captured all the data is getting analyzed, our neural network-based deep learning models are starting to identify what are some of the roof dimensions and wireframes and the damage. So the biggest ROI when Hurricane Harvey and Hurricane Irma struck, Farmers is one of our biggest customers. They were able to deploy their fleet and very quickly started inspecting the damages. And initially the status quo was that an inspector, in most cases, were inspecting like a roof or a damaged house, one house per hour. But with our solution, now their efficiency gains have tripled. So instead of doing 5 to 7 houses per day, that person is now able to do 15 houses. So the efficiency gains that they have received is enormous. In addition to that, the data is also very accurate because now we have automated the whole process. And in some cases, the data, the roof report is the end data product that is coming out of our pipelines was not available for a week or two. In this case, a roof adjuster or claims adjuster can immediately close the claim on the spot and achieve the customer satisfaction. That's the biggest ROI for most of our customers is the immediate customer satisfaction. The person who is struck by a catastrophic event is now able to see, okay, I'm going to get paid, I'm going to go back in my house. So those are the biggest gains we have seen in our customer space.
For us, I'll take the cybersecurity again. Some of our cybersecurity company customers are basically, I mean, the ROI is pretty clear. They're able to tell much faster if anybody's intruding into the networks, and which can potentially cut down to millions of dollars worth of damage, as well as really bad press out there. Obviously, you guys know that's a bad thing. So our engine came directly from that response, from perspective like even though it's applicable to all the rest of the industries too, but cybersecurity is kind of like where it came from. You're just basically making decisions in real time, trying to understand what's going on in real time, and basically mitigate the problem, because you're not going to stop it, but you're going to mitigate it and try to stop while it's happening, and basically mitigate the damage.
Really great examples. There are a lot of companies out there that are considering using AI, but they're still kind of in the research phase. What advice do you have for them? What questions should they be asking?
Well, I mean, AI gives you the ability to obviously, make, first of all, kind of make decisions 24/7, right? And it's, I mean, that's what AI never sleeps. You never really, never really goes, goes to the bathroom or like, needs a massage or anything like that. So like, he just learns and basically and applies that knowledge 24/7. And in many industries, obviously, that's an incredible. That's an incredible advantage that you're able to make decisions and your whole network, your whole infrastructure can basically become much smarter. And I think everybody has to ask themselves, I mean, this AI just is going to continue having a huge impact on every industry out there. So I think that's really the biggest deal.
So for us, one of the biggest learnings was that when we started automating parts of the workflow, we never imagined that we'll use deep learning models. We are going to solve some of the workflows. That was the intent. And then when we started addressing this problem space, we realized that there's some problems that are very arduous, that are very difficult for humans to solve at scale. At that point, these epiphanies stuck that we have to solve it using deep learning model. Take the example of hail detection. Now, hail the size of golf ball or hail the size of baseball, when it hits a roof shingle, it leaves a big impact. Now, the status quo was that person gets on the roof, that person is drawing a 10 by 10 square and manually counting the hail shingles that have been damaged. Now imagine doing that at a big scale, at like thousands and thousands of houses in the hail belt region. That's very difficult for humans to do at scale. Plus the consistency, you talked about the accuracy. AI is never sleeping. The other part is that the AI solution is very accurate. So you want to make sure that the consistency in estimating damage is applied across the board. And that only comes when you have automated solutions. So that was where the biggest learning was that we didn't go out with AI in mind. We actually discovered on the spot what are some of the solutions that are good for humans to solve and what are solutions that are good for machines to solve. So in that case, it was the biggest learning is that never start with an approach in mind. Go learn the approach or adopt an approach when you're on the ground.
Yeah, so I think everyone likes to talk and focus on the algorithms, the AI algorithms, but in fact, a huge amount of the expense and time spent around the process of doing AI is all the unglamorous parts of the work. It's the munging the data, it's prepping it, it's getting it into the right form, the one-hot vectors, it's visualizing it to look for interesting features, looking for outliers, and then it's interrogating the models that are produced. And so I think if you're implementing AI, you need kind of a support system around it or a platform that can allow you to do all this stuff at scale without needing to kind of pre-index or aggregate or spend a ton of time modeling data. So one of the nice things about us using GPUs is literally we have this kind of brute force supercomputer where we can query these billions of records and find interesting correlations and visualize those in milliseconds. And we also have we have something called the GPU data frame, which we did with H2O and Anaconda and NVIDIA, which allows us to seamlessly pass data back and forth where you can keep the data on the GPU, query it, visualize it, hand it off to AI, get the results back, and iterate.
Yeah, so I think some practical advice, whether you are creating an AI solution or a potential partner evaluating an AI provider, I would say is AI is progressively becoming less and less of an engineering problem and more of a data problem. So, making sure that you can easily get access to data and transfer with partners, and making sure that any time that you can provide that data as early as possible will save you a lot of lag time later. And also, I would say a separate detail is just around a lot of AI, specifically deep learning, has been seen as kind of a black box. And although the algorithms, you may necessarily not have a lot of insight into, if you're evaluating a partner, it is totally fair game to ask them to do a blind test with you. So a specific example in healthcare, say, give us 1,000 X-rays and tell us what you predict might be in them, and then you can independently verify whether the results are good or not. So, when you're trying to evaluate a partner, it's really useful to just make sure that they have like a baseline in mind that they can provide to you. And, if they can't give you a baseline estimate, they're most realistically don't have anything there, and they're hoping to get free data from you to create their first model.
I guess the advice I'd give is, start with your goals in mind. I think saying that you want to do AI isn't probably a good starting point. Start with like, what are you trying to influence? Is it a customer decision? Is it revenue? Is it cost cutting? And work backwards from that. Because I think, throwing machines and throwing models and algorithms at a problem isn't going to solve it. In fact, it may waste a lot of time. So I would make sure to start there versus saying you have to use a particular approach, because I think you'll end up down the wrong path if you go after that.
Just one other thing we learned is your algorithms are as good as your data is. So data collection is a very big problem, because all our data is high-resolution imagery, and we have to train our deep learning models on that high-resolution imagery. It required, we have to go through so many iterations to understand at what height the drone should fly, what should be the angle, how we should capture this data, and then how do we train the deep learning models, because ultimately acquiring the domain knowledge that you're serving in, that's a key. So we had to bring in hail experts who actually helped us understand this is a hail, this is a nail shadow, this is something else. So it takes a lot of iterations to do that. So acquire the right domain knowledge, make sure you understand what data you're capturing, how you're training your models, and ultimately, it's not about full automation, it's about, you mentioned, it's all about, we call it human augmentation. So it's all AI-assisted human decisions. Our attempt is not to actually kind of replace the entire workflow. Our intent is to cut down the workflow or automate few stages in the workflow. So that's critical. Data is critical, domain knowledge is critical, and then also setting the right expectation that this solution is not the panacea. It's not going to address everything that you have in mind. It's only going to help you make better, more smarter, more accurate decisions.
Jitender, so I really love that, AI augmenting the end user. What has the feedback been like from folks like insurance adjusters? What are they loving? How is the experience very different for them now?
Yeah, so as I talked about, the status quo is pretty manual. I mean, it's so dangerous. The roof inspection, or the roofing, is the 4th deadliest job in North America. So people have to climb roofs. They have to bring in a ladder assist. Sometimes they have to use harness. So in this case, the feedback was that this is godsend. This improves our efficiency. Instead of doing 5 inspections in a day, I can do 15 inspections plus. The data, the reports, everything becomes available on the spot. So that's a huge feedback. And as I talked about earlier, for insurance industry, customer satisfaction is the #1 reason customers will come back. So if your customers are not satisfied, if you did not address the claim on the spot or in 2 to 3 days, it's pretty much a lost customer. So for the feedback that was that all the automation that you've done using deep learning is really helping us achieve our own customer satisfaction goals.
Awesome. Devon, can you maybe chat about how you're augmenting radiologists? I'm curious about what the experience is like for them now.
Sure. So I'd say there's some background processes that we do and some foreground workflows. So specifically, imagine you have a hospital that is understaffed. They don't have that many radiologists. They have this big backlog of patients that may get seen late or really never at all. So one of the things that we're able to do is help prioritize those cases. So imagine the 1% of patients that actually have a problem. We're able to interface and prioritize those cases where the people that need help are actually getting the help, and you can focus your resources and service more patients in that capacity. With your existing staff, you don't need to double your work staff. You can exactly have more support. And as far as the specific workflow of integrating with existing radiologists, they're responsible for everything they see in an image, even though if they're supposed to just be screening for something specific. So what we can do is when they pull up new images, give them a little overlay or a heat map or some textual information describing, hey, we found such and such in this scan. Maybe you should check that part out.
Awesome. Alan, can you maybe talk about how you've changed kind of the experience for your end user? What are they loving? What are they excited about?
Well, I mean, we play kind of in a real-time aspect of basically looking after data. So all the data coming in comes in and pre-processing it, basically applying particular models to real-time data, like a segment, and then passing that through to the to storage or processing, in the back end and deep learning and stuff like that. So, what we have kind of made our customers look at is the data that they're actually collecting, and which part of that data is actually is great to actually look at in real time, meaning like, make decisions as it comes in, because now with a power GPU and, we use, as Todd pointed out, we use GPU data frame really heavily everywhere. So like, so there's just the whole pipe is really fast right now because we can process millions of threads at the same time. And we can actually look at this data in real time. So, customers are identifying now, previously unknown uses for their data when it comes to real time, and when it comes to actually understanding what's going on, like as it comes in. Now, some of the customers, we're seeing that they're actually identifying parts of the data that can be processed real time that can actually become their kind of like revenue generating data, and because they didn't have that actual ability in the past. And some customers are basically they're seeing just incredible. Incredible ways they can actually apply their AI modeling and everything, and the deep learning algorithms and everything into the real-time data they have not seen before. So they're just kind of opening their minds to to a different segment of the data processing, that in a whole pipe.
Nice. Todd, could you maybe talk about how MapD is augmenting, end users? How have you changed the experience for them? How are they doing it before, and how is it just a little bit nicer now or faster?
Yeah, sure. So I'd point to one of our customers, Jam City. So Jam City is a relatively big gaming company based in Southern California. And before MapD, they were basically using, I think, Teradata. So you had this huge divide, right? You had the kind of data engineering, and they were using Teradata. You had analysts, they were using Tableau on top. And then you had data scientists who were doing building various ML models on the data. And so you had these various silos, and so once they started adopting MapD, basically it gives them, for the first time, right, the end users, including the data scientists and the analysts, can easily get their own data into the system without doing a bunch of engineering, pre-processing, pre-aggregation. And so all of a sudden, that basically means that they don't have to do week or 2 week JIRA tickets just to look at a particular data set, and that allows them to iterate, look for features, look for interesting aspects in the data, and their data is constantly changing, right? This is streaming. So an ad that may give them lift for better user acquisition today may not perform well tomorrow, right? So it's a constantly real-time thing where they're making these real-time tactical decisions, and they want to build models on it. And so MapD has kind of bridged these various silos in the organization, allows them to have one view of the data, and allows them to move much faster.
And William, could you maybe talk about how your product is augmenting folks as well too?
Yeah, so in our product and when we're working with customers, a lot of it's about improving the efficiency around doing data science work. So what we've heard is that a lot of the roadblocks come in coordinating development efforts with engineering, with other stakeholders. So we help them remove some of the roadblocks that get in their way, like how do we scale up compute resources very quickly? How do I get access to data? How do I make sure that the environments that I'm using are set up in a way that is approved by the broader data science team? So what we're seeing is a lot of momentum around data science teams now starting to establish best practices internally. So before it was sort of a scattershot approach. Everyone's trying their own thing. There's a lot of experimentation, and more we're seeing that data science teams are coordinating efforts. And at some of the bigger companies out there now, there's even centers of excellence that are being created, and this is really helping to streamline the process and improve how people go from the first day on the job as a data scientist to actually being productive. So that's what we're seeing a lot of our clients are doing now.
On that topic, what advice do you have for folks who are just starting out in the data science field? Where should they be looking for more info? What are your kind of tips?
Yeah. I think one of the blessings and the curses of the data science world is there's just so much information out there. What's the best way to navigate through it? I'd say a good starting point is always going to be your internal team. So starting with source of truth data. So sitting down with data engineers internally and understanding, how does the data actually get created that we're consuming internally? And it may surface opportunities to create new data sets that don't exist today or restructure what they have. So I think that's always the kind of best initial onboarding. in terms of training resources, a lot of it is domain specific or vertical specific and role specific, so there's probably no one recommendation you could give to a new data scientist there.
Awesome. So as you guys know, every great product takes great customers, a great community, and most importantly, a great team. How do you guys empower your team to do great work and build world-changing products?
I guess I could take that too. I think for our team, a lot of it's about individual ownership. Applying agile approaches to development. We definitely apply what we preach to our customers in terms of best practices. We want to follow agile development best practices. We use a very modern tool set, and we're not just throwing in new tools because they're available, but it's actually, hey, it's giving us marginal improvements and continuous measurements. So like, are we getting better at how we ship our product? Is the number of bugs going down? What's our customer satisfaction score? So a lot of it's making sure that individuals that are responsible for all of those metrics understand that that is their goal and they're tasked with doing that. And if they do it well, they see performance rewards for that.
If I can add to that, at Kespry, the most common word we use is workflow, because all our applications are workflow centered. So our ML team has a very clear ask. They say, don't tell us what to do, don't tell us how to do. Just tell us the workflow and tell us the customer experience. So if you're building customer-focused applications, understanding their workflow and understanding the stages in the workflow that can be automated, and then give the full power to your ML team, they'll figure it out. They'll figure out whether this is a deep learning problem, whether this is a computer vision problem, whether this is something completely else, which should not be addressed using any AI solution. So we always say in our companies that empower but track. So we just say, here's a problem. How would you solve it? Is it something humans should solve it? Should there be a fully automated AI solution, or should there be AI-assisted human decision-making solution?
Yeah. So I think in terms of trying to get data scientists or researchers excited to work, I think in general, whenever there's a clear goal in mind, of course that always helps. But in particular, being able to have quantifiable metrics where you know exactly like how you're progressing on these things, and you know what direction and what things you're actually trying to optimize for. Because of course you can try and solve every problem under the sun, but it's nice to solve a few things very well. Aside from transparency, I think it's nice to give creative outlets for your data science team. So make sure that they can either have interesting side projects or a particular experiment that's a passion project they want to work on, or even making sure you dedicate time just for keeping up to date on recent research papers or sharing research across your organization, because those new insights, a little bit of perspective can really push your product forward in a big way.
Absolutely. Todd, if you want to also share.
Sure, yeah. Just a little more philosophically, and this may not be applicable to everyone, but we recently went open source back in May of this year, and I think that's been a tremendous boost for our team. For the first time, it's great to have a set of customers, but knowing that you're developing something for a much broader audience, even people who will never pay you, I think that's motivating in the sense that you're empowering the world to do better work with the platform you're building. And second, I also think there's a transparency there, right? I mean, I hate to be blunt about it, but when you know that 100 people are going to look at a line of code you wrote, it makes you take more care. So I think that's been a great step forward for us.
And Alan, if you'd like to share.
Yeah, I mean, in our company, basically, we kind of give power to every engineer and developer to basically question everything, right? Like how things are done and how can they be done better. But also keep kind of an eye on solving customer problems and understanding what customer problems are, because it gets lost in translation, right? Like what customer problems are, and engineers have their own ideas of how basically what problems need to be solved, and basically making sure that the engineers are solving customer problems, but also making sure that they question everything, meaning from everything how we're doing things, how they need to be done, and give them power to do that, and it gives them ability to basically kind of innovate and and even think of things that they're not possible before. So that's kind of how we approach everything.